Somewhere in the city of Invercargill, at the very bottom of New Zealand, an old man is pulling cast iron pipe out of a hole in the road. It's condemned gas pipe, the kind the council digs up and throws away, pitted and rusted after decades buried underground. To everyone else, it's scrap. To Bert Munro, it's raw material. He is going to carry that discarded pipe back to his shed and machine it into the cylinders of a racing engine. That's where this story starts, and it only gets stranger from there. Because in that same shed, Bert melts down old scrap pistons in a little iron pot over a blowtorch and a 5-gallon can packed with burning coke. He pours the molten metal into molds he shaped himself, and he casts his own pistons. He has no foundry, no machine shop, no fancy testing gear of any kind. The one measuring tool he trusts for the fine work is a bicycle spoke he has notched by hand, and he has no way to check whether the metal he just poured is any good except to look at it. In his own words, he could just tell. Now here's the part that should stop you cold. This engine, built out of dug-up gas pipe and melted down junk by a self-taught man with a blowtorch and a good eye, ran at over 190 miles an hour. Out on the salt flats in America, it became one of the fastest machines of its kind on the entire planet, and it set a record that is still standing today. You've probably heard the name Bert Munro, maybe from the film. But the film doesn't really show you this. It doesn't show you how a man with almost nothing built a world-beating engine out of garbage, one handmade part at a time, in a tin shed at the end of the world. So that's what we're doing today. We're going to take the whole machine apart, piece by piece, and answer one simple question. How is any of this even possible? Grab a coffee. This is the build. To understand what you're looking at, you have to understand where it was built and with what. Bert Munro worked out of a small shed in Invercargill, a town near the very southern tip of New Zealand, about as far from the world's engine factories as it is possible to get. He didn't have a workshop full of machines. For years, he had essentially one proper machine tool, an old British Myford lathe, about 3.5 inches, and it was already around 20 years old. He had a grinder he had built himself. He had files, a hacksaw, a blowtorch, and not a great deal else. When he needed to measure something to a fine tolerance, the tool he reached for was a bicycle spoke that he had notched by hand, and he used it like a micrometer. He also had almost no money. This was never a funded project. Munro had more or less handed his life over to this one motorcycle, to the point where he once said, and I'm quoting him directly, "I've put more work in on that bike than I have making a living." That's not a figure of speech. He genuinely chose the machine over almost everything else a normal life is supposed to contain. And on one wall of that shed sat a shelf, and Bert had a name for it. He called it Offerings to the God of Speed. On that shelf he kept the wreckage, the burnt pistons and the snapped connecting rods, every part that had ever failed on him. Over about 50 years, he reckoned he blew that engine up somewhere around 250 times. Most builders would quietly hide their failures. Bert put his on display because to him that shelf was a running record of everything he had already learned, everything that didn't work yet. Keep that shelf in the back of your mind because it's really the key to this whole story. That shelf even gave a film its name. When the New Zealand director Roger Donaldson made a documentary about Bert in 1971, while Bert was still very much alive, he called it Offerings to the God of Speed, after the words on that shed wall. And Bert's whole attitude to the constant wreckage was exactly what you would hope. As he put it in that film, if a thing's worth doing, it's worth finishing if you can. I'm not going to give up until I get a good run. So let's take the machine apart, starting with the single most important part of any engine, the cylinders. The cylinders are where the fire happens, where the fuel actually burns and drives the pistons down. They have to survive enormous heat and pressure over and over without cracking. A factory would cast them from carefully specified iron, mixed and tested to a known recipe. Bert cast his out of old gas pipe, specifically condemned cast iron pipe from the city gas works, the kind the utility dug up and threw away when they replaced the old underground lines. This stuff had been buried in the cold ground for something like 40 years, and Bert had a theory about that. In his own words, he used Very old city gasworks pipe, cast iron condemned. He believed all those decades underground had seasoned the metal, relieved the stresses locked inside it, and left it stable and settled and ready to machine. The walls were thick enough, around ½ an inch, to give him the material he needed. So the burning heart of a record-setting engine was made from pipe the gas company had thrown onto a scrap heap. Then, the connecting rods. These are the parts that link each piston to the crankshaft, and they take an absolutely brutal beating, getting yanked and slammed thousands of times every minute. If a rod lets go at speed, the engine basically detonates. Bert kept snapping ordinary rods, so he started making his own, and he carved them by hand out of solid axle steel, then hardened and tempered them himself until they would take around 143 tons of tensile strength before giving up. When he traveled to America to race, he carried those hand-carved rods across the entire planet packed in a rawhide suitcase. Now, there is an honest little mystery here that I want to flag, because getting this right matters. Some accounts, including the famous 1968 Cycle World interview, say those rods were carved from a Caterpillar tractor axle. Bert's own writing and the New Zealand museum that holds the bike say a broken Ford axle. The likeliest answer is that he made more than one set over the decades, from whatever strong steel he could get his hands on, so both are probably true. In one of his own letters, he mentions carving out a pair of these rods and it taking him the better part of 5 months. Either way, the point holds. His connecting rods began life as a scrapped vehicle axle, and he shaped them with hand tools. Which brings us to my favorite part of the entire build, the pistons. The piston might be the most abused part in any engine. It gets slammed up and down thousands of times a minute, it sits right on top of the explosion, and it runs white hot. Getting a piston right is difficult even with modern equipment. Bert made his in a way that sounds completely invented, right up until you read him describing it himself. He collected scrap aluminum pistons, and his favorites were old British Ford ones. He melted them down. And the furnace he used to do it was a blowtorch, a 5-gallon can packed with burning coke, and in his own words, a wee iron pot. That is the entire setup. No proper foundry, no controlled furnace, just a tin can full of coke and a little iron pot heated with a blow lamp. He poured the molten aluminium into molds using dies he had filed himself out of a lump of tractor axle steel. Then he turned the rough casting down on that 20-year-old Myford lathe and finished it on his homemade grinder. And here's the detail that makes engineers wince. He had no way to test the metal. None. No lab, no hardness tester, no way to spot the tiny hidden flaws that make a piston shatter at speed. He judged it entirely by eye. His own words were simple. I can tell when I have a good piston, and I try to get the metal as hard as possible. That was the whole quality control department right there. Experience and a good eye. At first, making a single piston this way took him a full week. Later, he got so practiced that, quoting him one more time, "It used to take me a week to make a piston. Now I can make one in 24 hours. Sit with that for a second. A man alone in a shed, hand casting a race-quality piston out of garbage in a single day. And when he couldn't even get the raw aluminum he wanted, he improvised around that too. At one point, unable to find the proper alloy anywhere in New Zealand, he reportedly resorted to melting down aircraft parts, the alloy from an old DC-6 airliner propeller, just to get metal good enough to pour. There was no shortage he would let stop him. He would simply go and find something else to melt. If watching one stubborn man out-engineer entire factories with a blowtorch and a good eye is your kind of thing, that is basically the whole reason this channel exists. So do yourself a favor and hit subscribe. Because so far, we've only covered the parts that burn. Wait until you see what he did to the rest of the engine. With the cylinders and pistons handled, Bert went to work on the guts of the motor. And this is where you can see that he had gone way past simply repairing an old bike. He was redesigning it from the inside out, part by part. The Indian Scout he started with back in 1920 was a humble machine. It had a side valve engine, a little 600 cubic centimeter V-twin, good for maybe 55 miles an hour straight off the showroom floor. Bert threw most of that away. He converted the old side valve design to overhead valves, and he replaced the original camshaft arrangement with a 4-cam system of his own design, filing and grinding the cam profiles by hand. By his own account, he spent 800 hours in a single year, 1963, just doing that 4-cam conversion. 800 hours on one part of the engine by hand. He remade the bottom end too. He forged new flywheels under a steam hammer. He took the original crank pin and machined it down from about 7/8 of an inch to 3/4, then sleeved it back up to a full inch to get the strength and the geometry he wanted. To get all that power to the back wheel without slipping, he built a clutch with 17 plates, and he ground the teeth clean off the clutch body and hand-filed a whole new set so it could drive a 3-row chain. In his own notes, he even recorded the spring pressure he was running, well over 1,000 pounds of it. Every single one of those numbers is a decision he made and executed alone in that shed. And slowly, over the years, that 600 cubic centimeter motor grew. He bored it out again and again and again. It went to around 850 cubic centimeters for his first American record in 1962, out past 900 cubic centimeters by 1966, and all the way to roughly 950 cubic centimeters by 1967, right up against the ceiling of the class he was chasing. His biggest bore ever eventually took the old Scout past 60 cubic inches, a wild amount of engine for that little 1920 frame. And this 4-cam V-twin wasn't even his first radical top end. Years earlier, he had already built and raced a completely separate experimental single-cylinder engine with twin overhead cams, essentially to teach himself. The record engine was the culmination of decades of that kind of relentless tinkering. It was the same basic engine from 1920, bored, reheaded, recammed, and rebuilt so many times that almost nothing original was left inside it. Now, a powerful engine is only half the problem. At the speeds Bert was chasing, the air itself turns into a wall, so he built a body. By the mid-1950s, he was shaping a long, smooth, streamlined shell to wrap the whole bike and slice through the air. And true to everything else about him, he made it by hand. The first shell, which he worked on from about 1955 to 1960, was built from 8 separate sections of aluminum, each one hammered into shape by hand and fixed onto internal stringers with sheet metal screws. In New Zealand, under that first hand-beaten shell, the bike was already running better than 160 miles an hour. Later, he took that aluminum shell and used it as a plug to make a fiberglass copy, laying the fiberglass up over about 91 days, and then used that copy to mold a third. So the sleek body on the finished machine is a hand-hammered aluminum shape, copied into fiberglass and copied again. And a hand-built shell like that, at those speeds, was its own kind of terrifying. Sealed inside it, lying flat on his stomach, Bert had to hold a machine that could weave and wobble hard as the air fought against it, with almost no way to get out if things went wrong. He wasn't only building an engine here. Every time he sealed himself into that shell, he was betting his life on his own hand-beaten metalwork. And I want to be straight with you about one thing here, because accuracy matters on a build like this. You'll sometimes hear that Bert shaped that body over formers made from fence post stakes. I went looking for a solid source for that, and there just isn't one. What the record actually shows is hammered aluminum panels over metal stringers. It's a small thing, but if we're going to properly admire the real build, we should get the real build right. So, what did all of this run on, and what did it cost him? For his official record runs, Bert ran the engine on methanol. That's worth stating plainly because the story often gets muddled. When Cycle World examined the bike, they were specific that the records were set on straight methanol, without nitro. But when he was experimenting and pushing hard for more, Bert did run nitromethane, a savage, powerful racing fuel, and he simply couldn't buy it back home in New Zealand. So an American family who sponsored him, the Pierces, used to bottle nitromethane up in old wine bottles and ship it out to him so he could keep developing the engine over the New Zealand winter. And that nitro is a big part of why the shed had that shelf of dead pistons. The fuel that made him fast was also savage on the home-cast pistons he was feeding it. He would melt holes clean through them, which is the tragic little engine at the center of this whole story. Almost every answer he found created a fresh failure. He'd solve one problem, gain a few miles an hour, and blow the motor apart in the process, then walk back into the shed and cast another piston. In one single month, by his own testing records, he made 17 speed runs and blew the engine up 11 times. And the timing of those failures could be cruel. By his own account, some of the very worst blow-ups happened barely a day before a record attempt, forcing him to strip and rebuild the whole engine through the night. He was forever experimenting with fuels and mixtures, and he had a wonderfully dry line about one American alcohol blend he tried, noting that it sure was the best piston burner he had ever come across. Even his jokes were about melting his own engine. But here is what all of it, the gas pipe and the axle steel and the jam tin pistons and the 250 explosions, finally added up to. Out on the Bonneville Salt in America, on one timed pass, that shed-built machine was clocked at 190.07 miles an hour, the fastest speed ever officially recorded on an Indian. His 1967 record in the under 1,000 cc class was later corrected to 184.087 miles an hour, and it is still standing today. And on one uncompleted run, the bike was timed at over 205. All of that from dug-up pipe and melted scrap. So the next time you see that little silver machine, remember what it actually is underneath the paint. It is cylinders cut from condemned gas pipe. It is connecting rods carved from a scrapped vehicle axle. It is pistons poured in a tin can with a blowtorch and judged by a man's naked eye. It is one old lathe, one homemade grinder, a notched bicycle spoke, and a shelf full of failures in a shed at the bottom of the world. Burt Monroe built himself a fast motorcycle out of pure garbage over 50 patient years, and he made it faster than very nearly anything the factories could build. That shelf of broken parts was never a graveyard. It was the notebook, and the machine is the proof.